All right, now we're ready for question number 4. So, an archaeological dig is marked with a rectangular grid where each square is 5 feet on a side. An important artifact is discovered at the point corresponding to negative 50, 25 on the grid. How far, what's the distance between that point and the control tent, which is at the point 20, 30? All right, so let's try to draw what this looks like on our grid. They tell us that there's an archaeological grid and that an important artifact is found at the point negative 50, 25. So 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Here's negative 50. 5, 10, 15, 20, 25. Here's the important artifact at the point negative 50, 25. And they tell us that the control center, command center, control tent is at the point 20, 30. 5, 10, 15, 20. 5, 10, 15, 20, 25, 30. All right, so that's at the point 20, 30. And so they want this distance. Now, once we find this distance, we will have to multiply by 5 because every square is 5 feet. So every square is not just 1 foot, every square is 5 feet. So at the end, we'll multiply by 5. But let's find the distance between these 2 points. Distance is equal to the square root in the change of x's. So let's say negative 50 minus 20 squared. Negative 50 minus 20 squared plus 25 minus 30 squared. Running out of room there. So my calculation is actually, before I get to my calculator, my distance is going to be the square root of negative 70 squared plus negative 50 minus 20, 25 minus 30. Okay. 70 squared on your calculator plus 5 squared, negative 5 squared on your calculator is going to be 4,925. And if you find the square root of that, that's approximately 70.2 feet. So on this scale, this would be 70.2. But we're told that each mark on the grid stands for 5 feet. So my actual distance is going to be 70.2 times 5. So that's going to be approximately 351 feet away. This artifact is 351 feet away from the control tent. And for our last application here, we're going to look at application of distance. We're looking at this picture, and this picture has a bridge, and here's the flat surface. So the bridge has an incline, and we have a flat surface here. All right, so the problem says that we took this photo from a cruise harbor, and we want to illustrate slope and grade. All right, so using this software, they could find the make and model of every car, and they could figure out the number of pixels All right, so in any case, the average car is 15 feet long, and the average length of the cars I could measure on the bridge were 34.4 pixels. So we know how long a car is, and we know how many pixels that takes in the picture. We can use that to figure out how long the bridge is if we know how many pixels the bridge is taking in the picture. So the length of the bridge is 2,709 pixels. How long is that in feet? All right, so we know that for a car, 14 feet is exactly 34.4 pixels. That's for the car. Okay, so for the bridge, we should be able to figure out how many feet if we know its pixels, and we know that it's 2709 pixels. And we love these proportions, two fractions separated by an equal sign, because these two multiplied together, of course our answer is going to be in feet, that's the units of the numerator, equals these two multiplied together. All right, so 34.4 times x is going to equal 14 times 2709. So 34.4x is going to equal 37,926, and divide both sides by 34.4. And this is going to give me the number of feet of the bridge, 1102.5 feet. So the length of the bridge is 1,102.5 feet. We're going to use that on the next page. Determine the grade of the bridge. So let's just write down here. Slope, if my slope was 0.574, if I was asking for a percent, that would be 57.4%. Slope is a decimal number or a fraction. It's not given as a percent. Another word for a percent would be the grade. So if you're ever asked for a grade, what you want to do is you want to find the slope. Let's say my slope turned out to be 0.362. The grade of that incline, or the grade of that road, would be a 36.2% grade. So grade is always a percent. All right, so let's go back to this one here. We'll draw kind of a little sketch here. We know that this is 1,102.5 feet. I was able to use the software and some math to determine that the grade of the bridge is 8.15%. That's the grade, which tells me the slope of this line is 0.0815. So the height of this side of this triangle is going to be 1102.5 times the grade. I should say times the slope. The grade has a percent in it. So when you multiply these two together, you get 89.9 feet. So this is 89.9 feet high. And the length of this bridge here is 1,102.5 feet. So this helps me with question number 7 here. What distance does the vehicle cover horizontally? In other words, now we're going to look for this side of the triangle. This is a right triangle, so Pythagorean theorem holds. Well, let's say we're searching for x. 89.9 squared plus x squared equals the hypotenuse, or the longest side, 1102.5 squared. And we want to solve for x. So this is 8,082.01 plus x squared is going to equal 1215506.25. Let's subtract 8,082.01 from both sides. So we're going to get x squared equals 1207424.24. So that's x squared. That's this side squared. We just want x. So to undo the square, we're going to take the square root of both sides. And that's going to be 1,098.8 feet. And that's my answer, 1,098.8 feet.